Good evening, everybody. It's morning over here, but hopefully everyone has enough attention left that might be able to enlighten you a bit on the program we have here at the University of Maryland in mechanical engineering. Again, for those of you not familiar with our university, we are inside the Beltway of Washington, D.C., which is the nation's capital here in the United States. So the capital itself is about 6 miles from campus, and we are one of the largest campuses by land in the country. We're, I think, number 2. So the campus technically is quite extensive, although most of the engineering activities take place in one part of the campus, and that's where most of the students will spend their time while they're here at the University of Maryland. And we do have a number of students in our programs at the graduate level who do online education. Many of them will be working for companies. Some of those are local, some of those are global, and they will usually complete a master's degree, although we have had students who've gone on to do PhDs as well remotely. It is a bit more challenging due to the nature of PhD activities, but it is viable. So, let's see. Not advancing on my slides. Can somebody advance the slide? My controls do not seem to be working. Oh, there it is. Okay, this is just me. So you heard about me, and again, I am Director of Graduate Studies in Mechanical and Reliability Engineering in the Department of Mechanical Engineering, and we have 2 programs, so that's why it's Mechanical and Reliability. The Reliability program is a little bit newer to the university and to our department. It is fairly unique. There are not many reliability engineering programs in the world, and it is very distinguished. In fact, one of our former faculty was an NAE member, National Academy of Engineering, Professor Ali Mosley, and one of our former PhD graduates, Joan Kim, actually was CEO of Lucent Technologies. Again, those of you not familiar with the history of Bell Labs, it was a spinoff, and it represented some of the greatest technological advances that were made in the late 20th century. And he, Dr. Kim, he's also a professor of practice within our department, has become one of the primary donors to the School of Engineering. So here on campus, the central offices for the College of Engineering are in a building named after him, the Kim building. Why am I not getting some lag? Getting these to advance. I need to advance again. Okay, thank you. So, just to kind of give you an idea, I don't know how many of you actually study in mechanical engineering. Many times we will have graduate students that come from other engineering disciplines, even outside of engineering. Very common areas, for example, are physics. Some students come from biology because of the nature of the research that we do in mechanical engineering, computer science. Basically, the field of mechanical engineering is more geared towards aspects such as finding new ways to utilize materials for various applications, for example, automotive structures, aircraft structures, where we need stronger materials, higher strength materials and composites, and finding ways to develop principles in order to advance the integration of these materials into those technologies. Another facet that's very important and unique to mechanical engineering is production of products. So there are many issues involved, such as lean manufacturing, scalability of production, even reliability issues, which is a primary topic area of our reliability engineering program. Again, as you know, every engineering discipline, I think, does nano now. And in addition, a lot of our mechanical engineering faculty are starting to work in areas involving nanomedicine, where they're looking at different technologies that involve, excuse me, that involve systems for delivering medicines at the nanoscale, from external sources to internal sources, and new technologies for interacting externally with internal nanoscale ingredients in fighting different forms of cancer. We also have had a strong effort in sustainable engineering, and that's one of the topic areas in our professional master's program that's fairly unique for our graduate program. So the other aspects that some people may not be aware of that actually reside within mechanical engineering, we do a lot of work in big data. It's very important in supporting a lot of the areas that I've talked about, and we have faculty who are very engaged in looking at big data, especially in the context of looking at advancing manufacturing, particularly desktop manufacturing, for example, your 3D printing systems that many of you now have had the pleasure of and learning about, and which many of our students here will. Also, energy systems has been very big for us. It is, again, one of the focus areas for our graduate program in our professional masters. An area that has been very popular of late is battery systems. We have an energy research center here at the University of Maryland that has had a large focus area in battery and portable micro generation systems, so that, again, it has the ability to provide extensive amount of power to remote locations or portable systems such as cars, boats, etc. Also, again, back in the context of manufacturing, the idea of being able to come out with construction principles.
I wrote it out in a sticky.
What's that?
If not, I could. If not, okay.
Is there? Okay. Hopefully, again, everything is okay. But the other aspect is a permanent modular approach to construction, where, again, finding ways to design and integrate structural elements so that they're portable and easy to assemble. And then, of course, the general area of biotechnology, nanomedicine is a sub-area, but we have a lot of faculty doing research in the area of human factors engineering and developing personalized medicine systems to support point-of-care applications that are very popular now for doing diagnosis, prognosis, and delivering medicine to remote areas. Next slide. Oh, no, too many slides. Do I have control? I've got control. So, just to give you an idea of some of the students that have gone through our professional master's program here, which is, again, one of the biggest graduate programs that we have. The professional master's currently has about 100 students in the area of mechanical, another 20, 30 that are in the area of reliability engineering, pursuing master's degrees. Again, it is a focus on courses only, so many of the students are not doing any research-related activities to receive their master's degrees, and many of them are pursuing it for a terminal degree, which means that that will be the final degree they receive in engineering, and they will then pursue a job. So their critical criteria is what the job opportunities are that they're going to get, which is what some of these alumni profile are covering. However, I will posit that with saying that we do have a number of professional master students that will go on to do PhDs. So Corey Redmond is a senior engineer at Stanley Black & Decker, which is up in Baltimore, Maryland, and he was part of our sustainability engineering program, and he has had an opportunity to work abroad with projects that were in Sierra Leone, Africa, and that was through the Maydell Williams Foundation. So again, a lot of our students have opportunities to work with undergrads on projects such as Engineers Without Borders, and have these unique opportunities to gain global experience that helps them when they're looking for job opportunities, since now a lot of companies are looking for people with international connections and they know how to do business abroad, because that is where we are now in the 21st century. We're in a global marketplace. Another alum of our program, Alex Chung, is an engineer at PassSA, and again, his area was in sustainable energy engineering, which again, PassSA is a local engineering company in DC, and the fact that he came here enabled him to get a job with PassSA, and that was what we find too that's unique about our program. The DC area is one of the most vibrant metropolitan areas in the United States when it comes to technology. A lot of that is because of the U.S. government being centrally located here, and thus supporting a lot of technology development activities through government funds to local contracting companies. Some of those contracting companies are fairly big, such as Lockheed Martin, General Dynamics. And so again, when you come to a program like, or you get affiliated with a program like the University of Maryland, these companies know us because they're right down the street. They trust us. They know what we produce, and they value it greatly. Somehow that went twice. Okay. Brian Fuqua is a PRA engineer at SAIC, which again is a support contractor for the government. Particularly in this case, he's working with NASA Johnson Space Center, and again, his expectations of the program, which were in the area of reliability engineering. Again, as I said, we have degrees in multiple different areas, reliability being one of those, enabled him to pursue a career supporting the activities of NASA. And for your information, there are not many people employed directly by NASA anymore. And the reason for that was they outsourced a lot of the jobs to contractors. So companies like SAIC emerged to support the consulting activities that were needed by these government agencies like NASA. And so many students will end up working with those kinds of companies after they graduate. And again, because of our position here, they know our students. Brian got an opportunity to work with NASA. Patrick Huddock is another graduate, an energy project manager at Intercap Energy Systems, again from our sustainable energy program. And the reason he got that position was because he was concentrating his studies in a new area that Intercap needed expertise in, that we are providing our students with some of the best education possible. And so as a result, he got an opportunity he wouldn't have had otherwise if he had not been part of our program. So again, these are just a few of the many graduates that we've had in our program. And the faculty who support the educational activities are quite diverse. In addition to myself, in the Department of Mechanical Engineering right now, we have 45 faculty members, one of which includes Dan Moat, who is the president of the National Academy of Engineering. And the department itself is led by Professor Balakumar Balachandran. His expertise is in the area of dynamics. And we also have Amar Baz, who has extensive experience as well in the area of dynamics, but also has been actively involved in a number of our educational programs here at the University of Maryland, including the Keystone program. Our former chair is Avi Bar-Cohen, who actually has spent 4 years serving as a program manager at DARPA. He stepped down. And I don't know why it says Director of Graduate Studies, but it shouldn't there. But he has, again, been leading $100 million programs at DARPA in the area of heat transfer systems, advanced heat transfer systems. Peter Bernard, who's another distinguished professor in our department who has an area of expertise in computational fluid dynamics. Professor Shapur Zarm, who actually has a former student, that Alex Mer, who started a company that, I don't know if you've heard of it or not, it's called Zeusk, but it is one of the, as I understand it, one of the biggest online dating companies in the world. And his area of expertise is design optimization, which actually is quite interesting because that's what Alex did in developing his company. Was he was working on a project where he was trying to figure out the best placement of systems for naval applications. And the algorithms that he developed, he thought, hey, I can apply those to humans. And I can match people up like I'm matching these systems up. And that's how he ended up starting this multi-million-dollar company. Also, another faculty, Sarah Bergbreiter, is a younger member of our department, and she actually is a pioneer in the area of micro-robotics. If any of you ever watched some of these TED Talks, she's given one of those, and she actually leads now our Maryland Robotics Center, which is a interdisciplinary center, so there are faculty involved from throughout the college and the campus, but nucleates a lot of our activities that we have in the area of robotics, which many of our graduate students will be participating in. All right, so this is a nice picture of our beautiful campus, part of our beautiful campus, the beautiful big red M that we have when you come onto campus. And basically, the campus itself is home to 10,000 graduate students. Within engineering, I believe now we are at 1,500 graduate students, and we have 5,000 or 4,400 total faculty approximately on campus, 200 of which are in mechanical, or 200 of which are in engineering. And then what you'll note that's very important is that Maryland is considered one of the most diverse campuses in the world. We have over 137 countries that our students come from. We pride ourselves on diversity. It helps us to nucleate new ideas, and it's very important to staying at the head of technology and developing new ideas. So again, we have many students actually that do come from India. I know it's very popular in many campuses to have students from India, but many of those students that we have contributed greatly to our academic activities. The school itself, this is the building I was telling you about, the Kim building, a picture of it that Joe and Kim donated money to build. And again, we're one of the top programs overall in the world. I will say our latest ranking in U.S. News and World Report is actually 21st. 5 schools that are ahead of us clumped at 16 all tied. It's like if you have 0.1 difference, you move up 5 spots. So I don't put too much credence into the rankings other than to say you probably have like different tiers that come out. And so at the top of those tiers are schools, again, like MIT, Caltech, Stanford, and then the next level are the, Purdue's, the Marylands, those institutions, Berkeley, those places. Again, I told you about our location, and I should say over 2,000 now total graduate students. One thing that you'll note is that we have been growing a lot over the past 5 to 10 years. And that's been evidenced by the exploding populations within our graduate program, which means more opportunities for students. And a lot of that is because our faculty members are some of the best in the world, and they're bringing in lots of research money. And a lot of the students here in the program will be supported through research assistantships, where they are responsible for deliverables on those research programs in order to be able for those faculty to get more papers out and to get more funding in to continue supporting their activities. So the support that we get from graduate students is very important. However, what students need to understand is that it's not a free ride. You don't get paid to play. They get paid to deliver research, and that's the key. Your academics really are, when you're getting a research assistantship, are secondary. So a lot of students for their master's would prefer to focus on their academics and then do research as a PhD. So they'll do, for example, 10 classes and get a degree like a professional master's, and then decide instead of going and getting a job, I'll continue on to a PhD. And in that case, in the mechanical engineering program, you just need 2 more classes and your dissertation to get your degree. So they typically can do that within about 3 years and focus almost 100% on just their research activities. So they'll pay their own way for their master's and then get paid to pursue a PhD degree. Again, the faculty that are advising them are fellows, including myself, of multiple societies, and recipients of distinguished awards, such as the Early Career Award. I received a Young Investigator Award from the Navy. But right now, we also have 19 National Academy of Engineering members. And as I indicated, Joan Kim is a member of the National Academy as well, and a professor of practice within our department currently. And Professor Ali Mosley, who was in our Reliability Engineering program, is also a National Academy member, and we include Dan Moat, the former president of the university, who is the president now of the National Academy of Engineering, as a member of our program as well. In fact, we have 6 National Academy of Engineering members that are affiliated with the Mechanical Engineering Department here at Maryland. And again, for those of you not familiar with it, the National Academy of Engineering is a very exclusive organization. It represents only the best engineers within the United States. They come from industry, they come from academia. There's, I forget the exact number exactly, but there's only probably a couple thousand members of the National Academy throughout the United States. So having 19 at one institution is pretty impressive. Okay, so this is an overview of the Masters of Engineering program. Again, I'm involved primarily in the mechanical and reliability aspects of the program, but there are other areas, cybersecurity, aerospace, civil environmental. We even have a new program in robotics that has become very popular very quickly. And again, one of the factors, Professor Sarah Berg, who's director of our Maryland Robotics Center, oversees the students within that program. Right now, the Masters of Engineering program is primarily domestic students, about 80%. So only 20% are currently international. That is not reflective of the general programs like our PhD programs here, where typically 40 to 50%, depending on which program you're in, are international students. So it is fairly newer in terms of a degree program at our institution. It's been around for about 20 years now. I think students are beginning to get aware. That's why we're having a webinar now, so you can learn more about it, of the opportunities that you can have getting a professional master's degree from us. And again, able to use that to advance either a career within industry or potentially continue on to do a PhD. There are 500 students currently within the Masters of Engineering program, so it is a significant part of our graduate student population. It represents 25%. And currently there's over 2,000 alum from the program and 74 faculty members involved. So in the Mechanical and Reliability Engineering program, we have numerous courses. I can show you that online. You go to our website at enme.umd.edu, and you can select the graduate program and a full listing of all the courses that we offer there. The Masters of Engineering program has also got its own website under advancedengineering.umd.edu, and there you can find duplication of some of those courses as well as some that are unique to the Masters of Engineering program. But most of the topic areas cover very fundamental advanced topics for mechanical and reliability engineers to know, such as advanced systems control, optimization methods, advanced material behavior, environmental risk analysis, basically topic areas that you have probably not had as an undergrad. I think sometimes you have that opportunity as an undergrad to take a graduate level course. Most students won't have been able to take more than one or two. So the idea is that we cover a broad range of relevant topic areas to the technologies that we were discussing. We also have courses, for example, in Nano Mechanics for nanotechnology and for robotics to support the robotics program. So there you can pretty much find whatever you want to study here at the university. Now the caveat on this is some of the courses that we're offering are offered online and on campus. Some are just on campus. So some of the students decide that they want to come to campus to take advantage of all the offerings that we have. So we do have quite a few students who are in our Master's of Engineering program that have relocated here in order to pursue their degree. But we still have students that will do it, like I said before, primarily offline, or primarily online, I should say, off campus, and get all 10 courses that they need, which represents 30 credits to get their degree. Okay. So for those of you not familiar, again, here is the web link that I just mentioned, advancedengineering.umd.edu. For applications, you do /apply, /apply. We're looking for students that have GPAs of 3.0 or better. To be honest, it's a very competitive program. I always tell students the higher the GPA, the better. Doesn't mean that if you have a lower GPA, you might not be accepted. I just think you have to be realistic that your odds drop precipitously as you reach that 3.0 mark. Again, areas that you can get your degree in have primarily engineering, but we do have students that do not have engineering degrees that pursue a Master's of Engineering from us, which again we also call a professional master's degree. So civil, environmental, mechanical, chemical, biomolecular, very common. The only caveat for your degree is it should come from an accredited institution, which most institutions I'm sure that you're affiliated with will be accredited. We, again, for students not engineering majors, often will recommend that they take courses that prepare them that are undergraduate level for pursuing a Master's of Engineering degree through us. So thermo, fluid mechanics, mathematics, these are all basic courses that some students in other disciplines may not have had, that if they take them, we will go ahead and consider them for admission into the program. And again, in certain areas, there might be some prereq requirements that students should have taken as undergrads, such as a strength of material, structural mechanics class. Many times we will waive those prereqs. You just have to request that you be considered by the instructor for a waiver, and you can still take courses even though you may not have had the prerequisites. It's just, to be honest with you, it's going to be more challenging because you're going to have to pick up those basic ideas on your own, and because again, graduate courses are going to focus more on the advanced topic areas. Deadlines for international students, which are important. For fall, you have to apply by February 1st. Again, a lot of that's predicated by the fact that if you choose to come here and do your degree on campus, you need time for a visa. So if you don't get accepted and start applying by that date, it's very hard to get onto campus by fall. In many cases, students might not make that. They'll decide they'll come in the spring. If they do, then they have until October 15th in order to apply. And usually the visa process is much easier in the spring because the State Department's handling far fewer applications from international students for spring admissions rather than for fall. If you want to know about the tuition and fees of our program, they're also accessible via advancedengineering.umd.edu. So with that, I'll be happy to entertain some questions. If I can get control of the internet, I might even show some things on the web too. I don't know if I can get.
Thank you, Dr. Brooks, for the wonderful session. We will address the questions. Or beforehand, would you like to show something on the internet before we start addressing the questions?
Well, I just wanted to be able to access the internet in case, when a question came up, I could show students something. If I can just get out of the presentation mode. I think students like to look at things on the web, not just listen. So they can look and then they can listen at the same time.
Okay, so Mr. Brooks, we have made you the presenter, so you can access it through your system and you can show the browser the questions and whatever you would like to show from your side, from your system.
All right, so students are going to ask me questions on this here, right?
I'm going to be asking the questions based on the questions raised by students.
All right, that sounds good.
Okay. So the questions of okay, first question by the students. Mechanical engineering concepts are involved in nanotechnology.
Okay. Are they? Is that the question?
Can you explain how core mechanical engineering concepts are involved in nanotechnology?
So one area is nanomaterials. So for example, we have one of our faculty members, Tong Li. He does a lot of work in modeling graphene, and a lot of that work is based on numerical simulations using techniques like molecular dynamics in order to predict how graphene structures might behave at interfaces with different systems and take advantage of their behavior at the nanoscale to create new concepts. For example, in the area of energy storage, so he has figured out how to get these, with his numerical simulations, these graphene structures to roll up in what he calls nanoscrolls and trap gases like hydrogen so that they can be used for hydrogen storage applications, even though inherently they don't absorb hydrogen. So it's a completely different kind of mechanism that the material is using to be able to be applied in energy systems. He's also done similar work in looking at how to model the behavior of nanostructures for phase transformation processes involved in battery structures, like in lithiation processes, using novel nanostructural morphologies that accommodate the expansion of the materials that occur, which often limit how you can use them in conventional battery systems as thin film structures. So he's figured out how to make like beads of these structures along fibers so that they can store more energy than a conventional battery system can. Again, a lot of the principles he's looking at are built upon what we call nanomechanics, which is an area within mechanical engineering the students can study. As I mentioned before, we have a course taught by Professor Dasgupta on it. So they'll have to learn the fundamentals of how we model the interaction between atoms and develop numerical simulations from those interactions. And again, that's probably most common. We have other faculty like Professor Bao Yang, who looks at using nanoscale ingredients such as nanoparticles to control heat transfer processes. So when he puts them inside of fluids, how does that change the fluid behavior that can enhance the conductivity and the transport of energy in order to make heat transfer systems more efficient? I myself have done a lot of work at integrating nanoscale ingredients into polymeric systems to improve the behavior of adhesives, to make structures that are lighter weight and stronger in the manner in which biological systems natural biological systems, for example, would use nanoscale ingredients to achieve very extraordinary properties where they're extremely lightweight, but they can be strong enough to even withstand a hurricane. And again, these are just a few of the areas I mentioned before. Nanomedicine, where again, people are, in faculty are looking at nanoscale ingredients inside the human system. Professors like Jenno Han are looking at trying to monitor these with external systems that they're developing for personal diagnosis. So, and also, I don't know if you want to call it so much nano, but some people are using that terminology for it. Professor Berg looks at very tiny robotic structures which start to traverse on the nanoscale, where her fundamental focus is on actuation principles, ways to make these robot systems be able to articulate through space so that they can actually be robots at smaller length scales. So those are just a few. I mean, there's a wide range. In fact, I often say nanotechnology is a misnomer because, to be honest with you, all material scientists and chemists have been doing nanotechnology for over 100 years. So we just recently started calling everything nano. The principles that we look at, again, are focused more on how to make systems like robots, like energy systems, out of nanoscale materials and principles. That's it. Next. Next question.
Thank you, Dr. Brooks. Next question we have from Aditya Shankar. He's a student from SRM. He wants to know the opportunity of being provided by university after job opportunity after the degree completion. And second, I'm interested in composite materials as I'm currently working for a team that makes super mileage vehicles for Shell CEO Marathon Asia.
Okay, so again, composites traverse more into my area, but we have other faculty within the department, again, working on these, such as Professor Dasgupta, in the context of electronic packaging systems. So it depends on what you're calling a composite nowadays. Your application would be what I consider more polymer composite systems, and that's more what I would work with. But again, a lot of the projects that we'll have in the area of composites that students will work on here will involve finding ways to change the chemistry of the composite materials and the way that we process them in order to achieve optimized material behavior and more multifunctional behavior. So the composite does more than just structurally reinforce. Actually be a battery in addition to structural reinforcement. So you don't have to have a separate battery pack if you've got, say, an electric vehicle that you're trying to make or an electric plane. So the students, because they would be working in projects like that, would have opportunities with companies who are now engaging in those areas, companies like Tesla, Google. There's a variety of different companies looking at now creating systems, so sort of like what Apple did with the iPod. So they started to realize we need to do more than just software, right? We need to do hardware too, because we need to integrate the two. And so they're realizing that that is the future with systems like composite materials, where they have to figure out how to make them compatible and more multifunctional so they interact with the information systems in order to better control structures. For example, an autonomous car that they're trying to develop at Google. So that is, again, a list of a few companies, students who are engaged in research and doing their degree might get into. However, again, a lot of students will just be doing their degrees and not being engaged in research in the professional master's program. And for those students, as I mentioned, there are many different opportunities that if they are located here on campus, usually they can find internships with some of those companies that I mentioned that our alum have gone to work for, or they may find a job after graduation. We, again, have job fairs several times during the year, and recruiters will come, and there's never a lack of opportunities to find jobs here at the University of Maryland. And again, the reason is that we are one of the top engineering schools in the country. So when recruiters are looking to optimize their time, they're going to go to the best places and find their people there and only go to other schools if they can't find what they want at a place like Maryland. And usually what we found is that they get what they want from us. So I hope that gives you a little bit more idea of what you can do with a degree from the University of Maryland in terms of job opportunities. I'll put it this way, nobody's staying unemployed with a degree from us, that's for sure. And they have some great opportunities with companies, like I said, like Google.
Unmuted.
Thank you, Dr. Brooks. Next question I have from Swarna Mukherjee. The question is that he's done his current projects in the field of fluid mechanics and computational fluid dynamics. Is migrating to aerospace engineering is a good viable option for him? And how is the easiest way of transitioning, he's asking.
So I guess the issue is that he wants to do a graduate program in aerospace, correct?
Correct.
And currently is a mechanical engineer?
Yes.
Is that correct?
Correct.
Well, I will again say that to me, at the undergraduate level, there's not much difference between a mechanical engineer and an aerospace engineer. I'd say that probably the only biggest difference might be they do a little bit more work with compressible fluid flow, since again, a primary fluid for them would be air. But that you do cover some of those topics as an undergraduate, so it's not like you're not familiar with what's involved there. You just may not have as much experience working with developing solutions for those equations. That's why you have graduate school, so you can get those courses. So what we'll find is a lot of times in mechanical, we'll say, fine, we'll take the aerospace engineer, they're great. And the aerospace program will do the same. They'll go mechanical engineer, great, they're a good fit for our program. And what I think is most important is whether or not you were very good at what you did as an undergrad with your degree program. So having a high GPA, having strong test scores. Again, at Maryland, since we do have a very large number of applicants, we find that many of them are able to achieve near perfect GRE quantitative scores. So the average in mechanical, I think, is around 166 now for the quantitative, and that's the most important score of the three. So again, as an international student, the only other prerequisite you really need is a TOEFL score. So you're supposed to get a TOEFL score of 100 or above. If it's a little over 100, it depends on what areas of the four that you are a little bit under to determine whether or not you can still be given full admission. But 100 is the cutoff. Your combined score is 100. You're good to go, no problem. Again, many of the students that get into Maryland will have higher than that because they are the best. So even in programs like Aero, that's what they're looking at. They're looking at those scores. They're looking at your grades. They really think that mechanical engineering is not much different than Aero, just like we don't think Aero is much different than mechanical. So I don't think there's any problems at all. And in some cases, what will happen is we'll have a student come in, they'll do a master's in mechanical and then do a lot of their coursework out of Aero as part of their master, and then they'll go into Aero and do a PhD. Or they'll just take and do a lot of coursework in Aero, and then they'll take their ME degree and get a job with Bell Helicopters or some other aerospace company. And vice versa. We also have students that will come in and do an Aero and master's and then do a PhD in mechanical engineering. So there's many different permutations there between those two fields, and I think they're highly, and in some programs in this country, they merge the aerospace and engineering departments. So we're a little unique in that we keep them separate from one another. Next question.
Thank you. Next question I have from Chetan, who is requesting, does any of the mechanical engineering programs are integrated with entrepreneurship?
With what?
Entrepreneurship.
Oh, yes. Well, we do have a big emphasis on entrepreneurship on this campus. In fact, that is one way Alex was able to get an opportunity to get some funding to be able to start his company, Zeus. But many of our students will also work with faculty and other students out of our business school at the graduate level. And we are looking at creating some new certificate programs in which students might be able to take public policy and other non-engineering degree, non-engineering subject matters for their degree that would enable them to be better prepared for careers as entrepreneurs or in other areas like, again, government service, civil service. So the reality is that a lot of that depends on your advisor. So for the professional master's program, I am the advisor. All students will flow through our office. I have an associate director, Carrie Poplar-James. She'll interface mostly with the students in developing their coursework plans. When we have a request from a student to take courses that are non-engineering, we do like for them to be able to achieve what they want from their degree. So we generally have no problem, as long as it's a legitimate graduate level course, we have no problem with them being able to do that. And we usually will do about 2 of those in a degree program. So out of the 10, we call them a little bit softer courses, since technically the content won't be as rigorous as an engineering course will be. But if it helps for a student to achieve what they need for success after their master's degree, we have no problem whatsoever of supporting them in that endeavor. And then, like I said, on campus, we have a whole organization called MTech, which you can actually go again online here. And they run from a building right next to the Chem building that supports entrepreneurial activities here through the University of Maryland. So they have even their own graduate programs too, and outreach programs. And a lot of students will work through there. In fact, the director of MTech is Professor Peter Sanborn, who's in our department of mechanical engineering. And so they are responsible for stimulating over $30 billion worth of growth in business within the state of Maryland over the last 30 years. So they've been very, very successful at helping to bridge a gap, so to speak, between academia and industry and involving students within those activities. So I think that's why I like having the web open when I'm doing these things, because I think you'll find a lot of answers right here on the web. You just need to know where to go. So I think, again, here is a prime example of what you get as an opportunity when you're here at Maryland. Now, the caveat is, again, that a lot of times students may do this on their own. So they won't be doing it with the advisors. They'll just go on their own. They'll try to find opportunities through these programs for themselves to be involved in. So again, they may not be doing research assistantship. They may be just self-supported and trying to go through these channels in order to prepare themselves for life after graduation. So it's basically like I like to think of life. We have opportunities in life, but it's up to us to take advantage of them. Nobody's going to hold our hand and pull us through it. So what I like to think is at Maryland, we've created as many opportunities as possible for students to be able to realize their dreams of becoming entrepreneurs, not only that, successful ones, like Professor Kim was as CEO of Lucent Technologies. And again, if you have any other questions, I'd be happy to answer them too. If you want to send me email, brock@umd.edu. I'd say the web pages that we have should give you enough information and more details. Next question.
Next question is there any research work happening for 3D printing?
Actually, yes. In fact, we have a couple of new faculty in our department, Professor Ryan Sokol and Mark Huge, who are working in areas of developing big data for 3D printing. That's Mark's area, and for multi-scale 3D printing, which is Ryan's area. So they will look at advancing the technology to the next level, where in Mark's case, they're trying to make smarter 3D printing systems so that it's easier for people to realize the concepts that they want based on the limitations of the 3D printing process and utilize big data in coming up with that decision making. So again, I would classify it more in kind of that artificial intelligence area. And Ryan's is more fundamental to materials itself, where he's looking at what limits the process when you're looking at making nanoscale structures using a process like two-photon photolithography, stereophotolithography techniques, which is what's the basis for the nanoscribe system. And then building that up into micro and macro scale structures using other techniques like conventional 3D printing processes. I myself do a lot of work with 3D printing based on metal systems and ceramic systems because my background has also been in functionally graded materials. So I've been working with pressureless sintering processes for almost 25 years. And that's fundamentally what these are. For metals and ceramics, they're sintering. For the polymers, they're more of a fusing process, fuse deposition process. So there are a number, and again, we're doing research. There are a number of people using the 3D technology and what they're doing. So, for example, Professor Ohadi, who I'm actually involved in a project on, is looking at making the next generation of heat exchangers out of polymers that are 3D printed combined with metal wires to enhance their thermal properties. So I can just keep going on and on all day if you wanted to, but I'd say that again, you can go online and again get to our department's website here, and you can find a lot of information just through the website, looking at our faculty and staff. Finding their, let's see if I've got Ryan's up here. There. Here's Ryan's website. I don't know if he's got his up yet. I think he got it up and active. He just joined us. I don't know what happened. Did I do something wrong? Where did it go? Oh, what's happening? Ah, there we go. So again, bio-inspired is the ideas that he's trying to promote with the multi-scale printing. So here's his website. You can learn more about his research activities here. See, isn't the web a great thing? So I hope that helps and answers your question. Next one.
Next question is, a lot of the students have asked on this particular question, what is the GRE requirement for the university for graduate program?
Right. So again, there's no official requirement, but if you want to be competitive, especially if you want to get something like a research assistantship, you need to, I think, be in like the high 160 range under quantitative GRE. Now again, I'm not saying that you should just do poorly on the other parts of the exam, but I'd say if you're going to put energy and effort, it better be into the quantitative one. Get the best score you can there. So doesn't mean we don't have students with less getting admitted. I'd say probably the lowest that's been admitted has been in the 150s, and about 157 or something in that range. And that's just because they've typically done a lot more outside of the classroom. So they might have been engaged in a lot of research and have had a lot of publications as a result. Or they have extensive work experience and have and are a more mature student, which is why they didn't do so well on the quantitative GRE, because they hadn't taken a quantitative exam like that in years. So we tend to give them a little bit more the benefit of the doubt. Sometimes we'll say, oh, take it again and get a little bit higher score. But I think if you are interested and you think you have a strong case outside of a lower GRE score, you should still apply, because again, that's just one metric that we're looking at in assessing students for opportunities. And for a self-supported student, you might be able to get in with a little bit less on an area like that than one who's trying to get support for their education through a research assistantship. Next question.
Thank you. Next question is by Radesh Shivashankar. Is that what are the graduate opportunities for electrical or hybrid vehicles?
So again, most of the work that we've been doing has been in support systems. So more of the structures, the battery systems for those platforms. We've been looking at building up a program for our undergrads where graduate students could be involved as mentors. That would be an electrical vehicle race program. But currently we haven't done that. So right now I'd say that they're a little bit more limited in that regard than in other areas that I've been talking about. There's certainly a lot of work that you can do that supports that, and I think students have to understand that too, in that when you are doing a degree, it's the fundamental knowledge that you're getting that's very critical to being able to get job opportunities. Nobody knows how to make an electric car all the way up from scratch. That's the reality. And that's certainly not going to be a master's student. So having just a program focusing overall on electrical vehicles, I think, isn't always the best thing, because what they need is specialization, subsystems. So again, if you're dealing with batteries, there are a lot of issues integrating them into electrical vehicle systems that require being an expert in batteries, not in electric vehicles. And again, through organizations here at Maryland, centers like the UMERC, the University of Maryland Energy Research Center. Again, you can find this online. I'll go here. That's what they're doing, is developing expertise, and students take courses that help them also develop that expertise. And in some cases, students might, so here's the UMERC Center, and you can learn all about that. It's run by Professor Eric Waxman out of the Department of Material Science and Engineering here. But I'd say even now, when you look at systems like robotics, a lot of electric vehicles share a lot of similarities with robotic systems. So gaining a lot of knowledge in an area like robotics can even prepare you to do things that we are going to have in the next generation of electric vehicles that are currently under development by companies like Google. So again, learning about information systems and such, that'll be the core to how these vehicles operate. That's how I think you need to be thinking at this stage if you want to be successful in your graduate program with a degree from us. Next question.
Thank you. Next question I have is, can I do a dual major?
Okay. Can they do a dual major?
Yes.
Well, we don't really have many official dual major programs on the book, mainly because one program is a lot of work. I'd say that usually students might do, for example, that's why we have certificates. So a student might do a certificate in information systems and then do a degree of Master's of Engineering in Mechanics. That seems to be the most popular combination. Some people might go and do like a cybersecurity degree, full master's, and then do a mechanical full master's. But generally, we don't have programs where you're double dipping, so to speak, and you're getting dual credit for 2 different degrees so that you can do it in, say, 14 courses instead of 20. So that we really don't have right now. Next question.
Thank you. Next question is it possible for to pursue, is there a opportunity of getting internship opportunity inside for the robotics program? This is by Aditya Shinde.
Yeah, I think that's the thing that, again, there's always a diversity of opportunities available to students. Some will come with research assistantships directly, some will come with self-support and then find internship, assistantship once they're on campus. I'd say that the opportunities, especially in the Master of Engineering program, are growing for students who are more open-minded, who can start off self-supported and then look for just getting paid to be an intern more so than the formal graduate research assistantship, mainly because the kind of work that's needed is beyond just technician work, and that's what usually most master's students are only capable of. After you get a master's degree, I think you're much better positioned to do the kind of work that we need out of research assistants as part of a PhD program. But if you wanted to come and you wanted to get some partial subsidy of your education through working as an intern within a lab, a paid intern, I think there are a lot more opportunities like that than ever before, especially in areas like robotics. And if you want to get it outside the university, again, I think we always have many companies looking for part-time help from engineering students. So I don't think you should have a difficulty being able to do that even as an international student. There are still opportunities available outside, and we've had, again, I myself have had students working as interns with organizations like the Food and Drug Administration, which is very close by our campus. So I think that's one of the advantages of the University of Maryland physically, is all the different government agencies that are just 30 minutes away from our campus, and all the companies that support them. There are just so many opportunities, and they really do like flexibility with their workforce. So they do like to have students coming in to help part-time to augment their activities. So I find that most of our students do find lots of different things that they can do to support their education, and do it with also the idea of gaining some experience outside the classroom. Next question.
Okay, I'll make this the last question. Any other questions? We can have it mailed to us so we can have it answered at a later bit duration. The final and the last question is, Buddy, what are the opportunities and selection criteria for graduate scholarship programs?
All right, so I hate saying it, but for scholarships externally, usually they're very limited to just having American, U.S. citizen, permanent resident applicants. I hate saying that. I don't really like it, but that's the reality of it. So the scholarships available from the National Science Foundation, other agencies, just are not in play for international students, which I deeply regret. But I don't control those things. So instead, we have internal fellowships that we can use to support students, and we do that within mechanical engineering, but there's very few. There's only like a handful available, so, and they're highly competitive. So it's very difficult to get those, and they're geared more towards PhD students than Masters of Engineering. There are also opportunities for students within the program, existing students who are pursuing PhDs, to get special support if they've had affiliations with certain institutions, especially in places like India. So we have a Kulkarni fellowship program that does support students affiliated there solely. So they don't go to anyone else. The students affiliated with the institutions in India through the Kulkarni scholarship program here at the University of Maryland, but they are pursuing, again, PhDs. So it's to help them, assist them in being able to pursue a dissertation in order to complete their PhD program. Scholarships are available online. In fact, we usually have the site here. Can't really so hopefully I'm getting this right. And we've set it up for our graduate studies program. So these are some of the fellowships that we've set up for students. But again, unfortunately, most of these are going to be external and designed for U.S. citizens, and again for PhDs. And these are our internal fellowship programs that we have within here. So all that information again is available online if you want it. Any other questions?
Okay, I'll make this the last and final question. Are there opportunities for internships during the summer for current BTech students? This is by Pratik Denny.
Yeah. So again, as I was answering before, that seems to be very popular now, is for students to be able to do an internship. Although in that case, for just a summer intern, they may not just be here. Sometimes those students will go to outside of the state of Maryland to pursue an internship. And some of those are actually affiliated with our centers here at the University of Maryland, in particular Department of Chemical Engineering. One of those is CALTS. So I'll show you that website.
So we will end the questions for now and this thing. So we'll end the session. So I would like to thank everyone for participating in the session. Also, a recorded copy of the session will be shared with everyone for their reference. Also, for the future webinar series, you can visit our website at www.els.in. Thank you.
All right, my pleasure. Thank you. Hope everyone got what they wanted out of this.
Thank you.
All right.